Guys, I hope you all are good and doing well for the preparation of your A2 mathematics. Guys, the topic today what we are going to discuss is about the differentiation for a parametric equations. Before we start the differentiation, we need to know about the meaning of parametric equations. So here you can go by the definition I write for you. Those equations for which the variables x and y are given as a function of a third variable, say t, it can be u, it can be any other variable, generally say t, the third variable. For example, x is a variable which is equal to, in term of t, 1 plus 4 sine t, and y equal to 2 cos t, and the domain of the t is from 0 till 2 pi. Here the variable t is called a parameter and the two equations are called the parametric equation of the curve. So this was a definition that it means there should be introduction of a third variable instead of two while differentiation, and that third variable is called parameter, and the equation formed by the relation of one variable with the third variable is called parametric equation number 1, and the second variable with the third variable is called the parametric equation 2. Here comes the question, what kind of question we have to solve. That is question is here, I'm going to write. Okay, say here is a question. The parametric equation of a curve r x is equal to t square, this is given, and y equal to 5 minus 2t, and we are supposed to find the dy by dx in term of the parametric equations. So here you can see we have x and t, so you need to differentiate with respect to variable, third variable t. So you write dx by dt here equal to d by dt of t square, and as you know, the applying the power rule, it will be 2 for t, and differentiate of t is 1 with respect to t. So dx by dt comes to be dx by dt is equal to 2t. I got this. Differentiate of the first term x with respect to the third variable t. Similarly, I need to differentiate this the relation between y and t again with respect to t. So I will get dy by dt equal to d by dt of 5 minus 2t, and it means dy by dt will be finalized as minus 2, because you know the differentiate of a constant is 0 and differentiate of t with respect to t is 1, so we get this one. As we are interested to find dy by dx, and guys, in AS, you know, we have done the topic rate of change, that is same thing. You can use the chain rule. We call this by using chain rule. And chain rule, like here, I'm going to explain you with here. Yani x was in term of t and t also was in term of y. We can write y in term of t and t in term of x. We can write like this. And we are interested to find dy by d of x. What? Dy by d of x, first and last. T is a sandwich between the two variables. So that can be as calculated as dy by dx is equal to dy by dt times dt by d of x, d by d of x, or you can write this term as dy by d of x is equal to dy by dt times 1 over dx by dt. That comes to be this one, right? This whole can be written as I wrote in the box, and this can be changed into this form. So it means dx by dt is, we need to take the reciprocal of this result, to put it here. So this is a chain rule. This rule, how I derived it, I hope it is clear to everyone. Now I just need to substitute the values here. Let's see how. We are interested to find dy by dx. So that is dy by dt times 1 over dx by dt. So dy by dt we got is minus 2 and 1 over dx by dt is 2t. 2 cancel, we get minus 1 over t is the right answer to find dy by d of x. I hope it is clear. Okay, the part A has done. Now we will go for the part B. In part B it is clear, find the equation of the tangent to the curve at the point where t is equal to 2. So from A we know dy by d of x. Part A we know from dy by dx is minus 1 over t. So we at t is equal to 2 given, we have dy by d of x, d of y by dt, sorry, we have to find dy by dt at t, dy by dx at t is equal to 2 is dy by dx at t is equal to 2 is minus 1 over 2, and this will give us the gradient m. So value of m is this, that will help us to find the equation of tangent. And also we need to find the the equation of tangent here. We know equation of tangent at point meaning x1 y1 with gradient m is y minus y1 equal to m times x minus x1. So we know the gradient, but we need to know the point x and y, x1 y1. For this in the question you are given x is equal to t square and y equal to 5 minus 2t. By replacing t2 in the given equations, we will get coordinate of x1 will be 2 square, that will be 4, and y1 will be 5 times 5 minus 2 times 2, that gives me 1. So it means the point x1 y1 for the tangent line will be 4 comma 1, and gradient already we have calculated. So by using this in this rule, I can highlight the rule. I will get required equation of tangent is y minus y1 equal to m x minus x1. You can further simplify to write it finally as y equal to minus 1 by 2x plus 3. That is the final answer. I hope it is clear. Let's go to next question. Yes guys, here's another question. Question 2, you can say, given the parametric equation of the curve are x is equal to 1 plus 2 sine square theta and y equal to 4 tan theta, right? For theta is lying between pi by 2 to 3 pi by 2. It means from 90 to 270. Find dy by dx in terms of the parameters theta. So simple is this. You need to differentiate first x with respect to theta. That will be dx by d theta. I'm going to write it directly, or let me do the step for you. For the newcomers who are, who are still learning for the rules, they need to know about d by d theta 1 plus 2 sine square theta, and this will be separated by 1 plus 2 d by d theta of, I did the steps, square here. You know the differentiate of a constant is 0, so it will be 0 to here. Here applying the power rule, first write the power, make 1 less from the power, and differentiate the function whose power we had, right? So dx by d theta will be 4 sine theta, and differentiate of sine theta, in the rule we know that becomes cos theta, and then theta with respect to theta, that is 1. So in short, we get dx by d theta is equal to 4 sine theta and cos of theta. This is the answer for the first derivative. Now similarly, we are given y equal to 4 tan of theta. So we find dy by d theta, 4 times d by d theta tan of theta. So dy by d theta will be 4 times tan derivative is secant square theta, and theta becomes 1. So we say dy by d theta is equal to 4 secant square theta. That is the derivative. Now by using chain rule, because we are interested to find dy by dx, by using chain rule, dy by d of x is equal to dy by d theta times 1 over dx by d theta. So here 4 secant square theta times 1 over 4 sine theta cosine theta, right? Because we need to flip it. 4 cancels, 4 goes with 4, we get secant square is 1 over cos square theta times 1 over sine theta cos theta. It means find that dy by d of x is in term of theta 1 over sine theta and cos square theta. I hope it is clear how we differentiate it. Now the second case says find the coordinates of the point on the curve where the tangent is parallel to the y-axis. Okay guys, one important thing, this is y-axis and this is x-axis. You know, at x-axis you need to note it. I am going to write a note gradient at x-axis is 0, because there is no rise and only run we have, so it's 0. And the second point is gradient at y-axis is not defined, anyway undefined, you can say undefined, because only we have a rise no run on y-axis, so it means gradient here will be undefined. As the line which we are going to find is parallel to the y-axis, so gradient here we will write b part, gradient at y-axis is undefined. And you need to know also that 1 over undefined is 0 and 1 over 0 become undefined. Keep this in mind as well. You will get the math error if you want to go with. So for the parallel lines, gradient of tangent that we are going to find, the coordinate point, the tangent is parallel to coordinates of the point For parallel lines, for the gradient of the curve is, we have calculated this one. So for parallel lines, gradient of the curve and the gradient of tangent are equal. So we can say 1 over sine theta into cos cube theta is equal to undefined, and just I can write it as flip the equations. Sine theta cos cube theta becomes 1 over infinity, and that is from here 0. So we can say sine theta cos cube theta equal to 0. Now from here we have to find theta. Sine theta once 0 or cos cube theta is 0, that means cos theta is 0 or sine theta is 0. So theta, from here I will find sine theta will be sine inverse of 0, that can be at 0 or pi, because the given range of the angle was pi by 2 less than equal to theta is less than equal to, what was there in the question, 3 pi by 2. 3 pi by 2. So it must lie in between. It was given. So accordingly we can find theta. We will ignore the 0. Okay, we take sine inverse 0 is pi, not 0, above pi by 2. And similarly here from cos theta, we get cos theta is what it should be. Your angle is here is not, sorry, it's lying less than theta, less than, it is this, not equality. It's lying in between pi by 2 and 3 pi by 2. Here you can see it is given. It is lying in between pi by 2 and theta. So cos theta is 0. So theta is cos inverse of 0. It can be when we have pi by 2. So that is not the part of our including in the values. So ignore. We will ignore this value and we will solve only this. Now theta is pi. So we can say we have to find the coordinates. So x was given to us in form of 1 plus 2 sine square theta, and y was 4 tan theta. Like I can show you. Yes, x was this and y was this. And I need to substitute the value of theta to find the coordinates. So at theta is equal to pi, x is equal to 1 plus 2 sine square pi, sine pi is 0, so x will be 1. Right, we can get x is equal to 1. And here what will be y? Y equal to 4 tan of pi. Tan pi is 0, so y equal to 0. Therefore the points where the tangent is parallel to the y-axis is x1, y0. I hope it is clear. We done this question as well. Okay guys, here's another question. Question states find dy by dx in term of the given parameter. Here the parameter introduced for the question is what? T. That is t. So here we have to differentiate the first with respect to t to get dx by dt and d by dt of e power 2t. The exponential differentiate we know. I'm going to write it directly. It will be e power 2t times 2, so it will be here. So dx by dt comes to be this result. And similarly dy by dt as the multiple of two terms, cubical term function and exponential function plus constant. So you need to write d by dt t cube e power t plus d by dt of 1. That goes to be 0 because the constant differentiate of a constant is 0. So here you need to apply the product rule, that is two functions are going to multiply, so u time v, you are well aware about it. I'm going to write for you here this directly, t cube and differentiate, you have to differentiate with et with respect to t plus et, now differentiate t cube, right? So we will get dy by dt as t cube e power t is e power t and t differentiate is 1 plus e power t and t cube will be 3t square. So we can write maximum et plus 3t square, et common, or you can take t square as well common, t plus 3 times t square e power t. This will be the dy by dt. I hope it is clear differential, how we differentiate this with respect to t. Now as we are interested to find dy by dx, so by using the chain rule, because t is connecting x and y, dy by dt dy by dx will be dy by dt times 1 over dx by dt. So using this rule again and substituting the results, we get t plus 3 times t square times e power t whole divided by 2e power 2t. Yeah, maximum you can simplify the like term by using indices, is fine, or you can write t plus 3 t square over 2e power t, because from 2t minus t will get e power t. This is the final answer. I hope it is clear. Right guys, this time we have a question, x is equal to 2 natural log of t plus t and y equal to 4 e power t, and we have to find dy by d of x in term of the parameters t. So we can differentiate the first, dx by dt 2 times d by dt of natural log of t plus 3, and here dy by dt 4 times d by dt of e power t. So you can differentiate this, you know well, differentiate of log function is 1 upon function times differentiate of function with respect to t, that is this. Okay, I will get 2 over t plus 3, and because this become 1 plus 0, that is 1, so no need to write. d by dt is, my answer of d of x by dt is this. Similarly dy by dt is for e power function is e power function time differentiate of function d by dt of t, as we are going to differentiate with respect to t on either side, that is parameter involved. So dy by dt will be 4 e power t. I hope it is pretty much clear to you guys. Now you know well what to do by using, yes, chain rule. By using chain rule, we know dy by d of x will be dy by dt times 1 over dx by dt, right? Now here just substitute the results, and I will get dy by d of x as dy by dt is 4 et, and here it will be you know the reverse of this with 2 divided by t plus 3. So you can write 4et times t plus 3 over 2. 2 will be cancelled with 4. We get 2et times t plus 3. That is my final answer. I hope it is clear. So this is how we are used to differentiate the parametric equation, and today we did the few questions based on parametric equations and how to find the equation of tangent or normal by differentiating the parametric equations, and the most important thing, how to apply the best use of chain rule. And this is we did along with the definition of parametric equation. I hope it is clear, and hopefully keep enjoying my videos, and inshallah time by time I will throw more and more knowledgeable video for you guys to help out for your A2 mathematics. Good luck. Bye bye.